Good afternoon, my YouTube viewers. It's Crystal here. I wanted to make another video for you, and this video is going to be able to make a log normal distribution in Python and Excel and test it. And I've got 4 tests that I was going to perform on this log normal distribution. But before we create the distribution, what you need to remember is you need to make sure that you go into the first spreadsheet on your workbook and ensure that you import all of the libraries that you're going to need to import. So one of the libraries that we're going to be importing is going to be stats models. So you need to make sure that you've got the appropriate stats models library imported, appropriate SciPy libraries imported, and then pandas, numpy, matplotlib, seaborn, and map. You need to make sure that you have the libraries that you need imported. So what we're going to do is we're going to do a log normal distribution, and I'm going to have to keep the video a little bit short today. The reason why is because I couldn't make a video this morning before work because I was waiting for a telephone call from my doctor. And so I couldn't make a video just in case I got the call. So I'm making the video now, but in 20 minutes someone else is going to be coming to see me. So that's why I've got to keep it a little bit short. But we're going to create 3 log normal distributions. We're going to get the means of those distributions just to see how they compare to each other. I set my alpha to 0.01. And the reason why is because on the Anderson-Darling test, their p-value was 0.03, which was less than 0.05. So I decided to set the alpha at 0.01, which is 1%. So you could set the null hypothesis. The thing about the Anderson-Darling test is it's based on a normal distribution. And then if you go into SciPy, you can set your Anderson-Darling test up for a number of distributions, and a normal distribution being one of them. But SciPy doesn't give you the p-value. So I had to use stats models. And stats models gives you the p-value, but it sets the Anderson-Darling test based on a normal distribution. So if your distribution isn't a normal distribution, then the Anderson-Darling test is not going to give you the correct answer. And so Anderson-Darling test sort of like made it because it's a log normal. So this distribution is a combination of a logarithm and a normal. So it just about made it, which is why I changed my alpha to 0.01. The Kolmogorov-Smirnov test is non-parametric, so that means it's not set on a particular distribution, which is why I've been able to have successful p-values on every Kolmogorov-Smirnov test and distribution that I've done so far. And the Shapiro-Wilks is another test, and the chi-squared contingency is another test. I've had problems getting the Shapiro-Wilks to work, and I've had problems with the chi-squared test. But I went ahead and included these tests in this video so I'll give you some experience with the code and experience with working with the test. So first thing we're going to do is we're going to look at the image of the distribution, and this is the log normal distribution. So the mean sigma sample size is 0, 0.1, and 1000, and log 1 equals np random dot log normal mean sigma sample size. And then we're going to plot the distribution using matplotlib, and it gives you a little distribution in the cell directly to the right of it, so you can see the distribution there. If you want a larger distribution, then what you would need to do is you would need to take several cells and you would need to merge them together to make one big cell, and then you would get a larger distribution. But I didn't need a larger distribution because what I really wanted to do was to conduct tests on the distribution. So I made three log normal distributions that were identical to each other. And then I checked the means of those distributions just to see what they were like. And so mean 1 equals log 1 dot mean. Mean 2 and mean 3 are essentially the same as that one. So you can see the means are very close together. And then the alpha, I made the alpha 0.01, so I could say that the Anderson-Darling test worked. But you can make your alpha 0.01, 0.05, or 0.1, whatever you want. And just to get the Anderson-Darling a chance for me to write about it, I made the alpha 0.01. So the null hypothesis means the samples are the same, and the alternate hypothesis is the samples are not the same. And so we're saying that you can look at the means and you can see that the samples are the same. But because the log normal distribution isn't quite a normal distribution, that's why the Anderson-Darling test didn't give you a higher p-value. So we're going to check the code for the Kolmogorov-Smirnov test. That statistic p-value equals ks.2 sample log 1 log 2, and then you're going to print out the statistic and the p-value. And the thing is this Kolmogorov-Smirnov test is checking 2 samples. But if you wanted to check only 1 sample, you could only check 1 sample because there is code for the Kolmogorov-Smirnov test for only a 1 sample test. It depends on what you wanted to do, but I wanted to check 2 samples. So the Anderson-Darling test is, we're doing it for a 1 sample. Statistic p-value equals normal AD log 1 axis equals 0. So you can see that it's giving you a hint that it's checking against a normal distribution because it says normal AD. So that's why it had problems giving you a high p-value because it was looking for a normal distribution. And it's not a normal distribution, it's a log normal distribution. But it was high enough that if I changed my alpha to 0.01, then I would be able to accept the null hypothesis or fail to reject the null hypothesis. The Shapiro-Wilks test is a stat p-value equals Shapiro log 1. So the Shapiro-Wilks test didn't quite get to be able to accept the null hypothesis. So that means it gave us a false negative because we know that the distributions are the same because you can see that the distributions have the same mean. And the chi-squared contingency test. So we have one chi-squared contingency that every time I try to use it, I get an error. So I tried to use, we have one chi-squared test that every time I use it, I get an error. So I decided to use a chi-squared contingency. And chi2 stat p-value DOF expected equals chi2 contingency log 1 correction equals false. And that gives you that. And it still didn't give me the output that I really wanted, so I wouldn't use it because it didn't give you the output that you really wanted, the p-value. It gave you a p-value of 1. It gave you a p-value of 1. So I guess in theory, you could say, well, you got your p-value of 1, but I'm still not 100% okay with it but I decided to go ahead and use it just to give you an example of different tests that you can experiment with. So we've covered the log normal distribution, the means of the log normal distribution, the alpha, which is 0.01 in this instance, null hypothesis, alternate hypothesis. We've covered the Kolmogorov-Smirnov test for 2 samples, Anderson-Darling test for 1 sample, Shapiro-Wilk test for 1 sample, and a chi-squared contingency for 1 sample. But the only 2 tests that I was really happy with was the Kolmogorov-Smirnov test and the Anderson-Darling test. So I'm going to have to close this video because, as I said at the beginning of the video, I had to keep it short. I've got someone coming to my house in 11 minutes. And so thank you so much for watching my video. If you like this video, please like and subscribe. And thank you again for watching it. I will be communicating with you soon in another technological video.